Alright, hello geometry. So this is the chapter 8 review, and here's how this is going to work. In the description below there's a link to a Google Doc with the questions that I'm about to go through, so go ahead and open that up before you watch the video, so that you can follow along while you're watching the video and also take some notes. Obviously this is going to be open book, open notes, open calculator, because I don't have a way to stop you from using any of those things. So open notes, take yourself some good notes, just like a regular test. The questions on the review are going to be very similar to the questions on the test, so as long as you took notes for this, even if you don't have all the notes that you took before quarantine and stuff, you should still be okay. So if you have notes that are still at the school or whatever, don't freak out. Also, don't freak out, there are no proofs on this test, because we haven't really gone through any of those while we've been going through the videos, and we only had like one section of this chapter before we got quarantined, so there is no proof on the test. Let's say hello to a cat. Okay, Mirage, you gotta move now. Oops. Okay, there you go. Alright, so at this point I'm going to assume you've gone ahead and opened up the Google Doc, and how the test is going to work is once you're done with the video, go ahead and email me and I will send you a link to the test. So watch the video first, unless you really want to wing it, I guess. Okay, so first couple of questions here are, there's a cat. First couple of questions here are Pythagorean theorem ones, so if you don't already have it in your notes somewhere, or if you don't already have it memorized, I would jot down the Pythagorean theorem. So a squared plus b squared equals c squared, and the thing you're going to want to remember along with that is that c is always your longest side. So the other two can be a and b in any order, your longest one's going to be c. Because really the big thing with the Pythagorean theorem is watching out for whether we're finding a or b, or whether we're finding c. So I'm going to assume you jotted that down by now. You probably already have it somewhere. But if it was in the notes that you had back at the school, now you've got it here. Okay, so we're going to call this a, we're going to call this b, we're going to call this c, and we're solving for c. So we're going to fill in a squared, so 28 squared, plus 45 squared, equals c squared, which is the thing we're looking for. Okay, 28 squared is just a number. 28 squared is, nope, not cubed, squared. 784. 45 squared is 2025 equals c squared. And 784 plus 2025 is 2809. And watch out for now, if we want c and we've got c squared, we want the square root of that. So go ahead and real quick make sure you know where that button is on your calculator. Where's mine? There it is. 2000. Which gives you 53. And if we're looking back at our triangle, yeah, that looks like a reasonable thing to get because our hypotenuse should be our longest side, but we're still in the same ballpark as 28, 45, 53. Okay, that's a reasonable thing to get. And that's a good thing to watch out for, but to make sure that you went ahead and square rooted that. If you just stopped at the 2809, obviously this is not the third side of a triangle where two of your sides are 28 and 45. That's way too big. That wouldn't be a triangle, let alone a right triangle. Okay. Over here, we're looking for one of your two sides, either A or B. I'm going to call it A. And just watch out for this time, B, that's C. So your longest one's always C. Sometimes it's the thing you're looking for, sometimes it's not. So now we get A squared plus B squared, which is 15 squared, equals C squared, which is 17 squared. So yeah, A squared, 15 squared is 225. 17 squared is one I should know by now. 289. And we're subtracting in 225. Those go. And I got 64. And if you happen to know off the top of your head that the square root of 64 is 8, cool. If not, plug it into your calculator and we've got 8. And again, that's a reasonable thing to get. We're in the same general ballpark as 17 and 15, and yeah, that's your shortest side. Definitely shorter than your hypotenuse, so we're good. We're in the right ballpark. Alright. Now, these next couple, If you happen to remember the couple of little rules we had for special right triangles, yay! If you don't remember those things and would just want to go ahead and Pythagorean theorem those, that's fine. That'll still work. So if we've got a 45, 45, 90 triangle, because this other one has to be 45 as soon as this one is, because right angles are 90 degrees, triangles add up to 180, so we're left with a 45. So if you happen to remember that means this is an isosceles right triangle. So that means that these two sides are the same, so W equals 4. Okay, we're half done already. Okay. And then if we want to find y, you could either go through in Pythagorean theorem, and now that we got the two 4s, or if you happen to remember that in a 45, 45, 90 triangle, your hypotenuse is your leg times the square root of 2. So if you happen to remember that, cool. If not, and you went through Pythagorean theorem, that's not going to take you that long. So either way, you got 4 times the square root of 2 gives you 5.65. And that was y. Try to make my y a little bit curly here so it doesn't look like 4. Alright, and watch out for here, we do want to find both of those things because both of those were variables. So sometimes you're going to be missing one thing, sometimes you're going to be missing 2. Over here we got 2. So that might be something to jot down with 45, 45, 90 triangles if you're not going to remember that one off the top of your head. Or, again, once you figured out that this is isosceles, you could Pythagorean theorem it. Okay, this one. So 30, 60, 90 triangle, because this has to be 30, because we've already got 90, we got 60, that adds into 150, triangles are 180, minus 150 gives you 30. Okay, so 30, 60, 90 triangles, the big thing you want to remember about that is that if we have the shorter side, and let's call that x, use x for there, your hypotenuse is 2x, and your longer leg is x times the square root of 3. So that's as long as we have a 30, 60, 90 triangle. So that might be something you want to jot down. So if we've got this side is that times 2, and this side is that times the square root of 3. Now, you might be looking at that going, but we don't have that side. We have this side. Okay, but if this side is this side times 2, then this side is just half of that side. So W there is just 5. Now we have this side. So now if we, that's right triangle. So now if we take that times the square root of 3, we get 5 times the square root of 3, which gives about 8.66. So y is 8.66. Now technically if you left that as 5 times the square root of 3, that would also be perfectly fine. And just a reminder that if you have one of those calculators where if you punch in 5 times the square root of 3, it spits back 5 times the square root of 3, just go ahead and take that times 1.0, and that tells your calculator, no, give me a decimal. Okay, so we got both of those things, and there you go. And again, once you figured out these two, you could get this one with the Pythagorean theorem, or technically you could use some of that SOHCAHTOA stuff we were doing later in the chapter to get that if you don't remember that these are a thing. But I would just go ahead and jot down those two special right triangle things, because that makes it a little bit quicker. So this one's 45, 45, 90, this one's for 30, 60, 90, and really the big thing there is just not getting them mixed up, because they both have square roots in them. This one's a square root of 2, that one's a square root of 3, so watch out for that. Alright, for these next couple, the thing you're going to want to jot down if you didn't already when we went through this the first time is that if a squared plus b squared equals c squared, it's a right triangle, that's one you probably remember. If a squared plus b squared is bigger than c squared, it's an acute triangle. If a squared plus b squared is less than c squared, it's obtuse. And if a plus b is less than c in the first place, that's not a triangle. So if you have something like 1 and 1 and 10, that's not a triangle. So then we don't need to do the rest of it. Okay, so if you didn't already have that jotted down, that's something you're going to want, because really the big thing is just not getting these two mixed around. This one you probably remember off the top of your head, but just watch out for remembering which way those things go. So if it's bigger, it's acute. If it's less, it's obtuse. Because all we're doing with these next couple is figuring out, does it give us a triangle? And if it is a triangle, then is it right, acute, or obtuse? So the first thing you want to look for is it a triangle? And it's a triangle if two of your sides add up to more than your third, and if that works for all three of your pairs. But really, the only one you need to check is whether your two smaller ones add up to more than your big ones. So 7 plus 7 is bigger than 9, so yes, that's a triangle. Okay, now we're going to square. So 7 squared plus 7 squared. And again, 9 squared over here. 7 squared is 49. 7 squared is 49. 9 squared is 81. 49 and 49 gives you a 98, which is bigger than 81. So if a squared plus b squared is bigger than c squared, that makes this acute. So that one is a triangle, and it's acute. Oh, what a cute little triangle. I can hear your pity laughs right now. Okay. So let's say we got 4, 5, and 10. So again, the first thing we want to check is it a triangle? So we got 4 plus 5. And we want to make sure that's bigger than 10. 9 is not bigger than 10. That's not true. So this is just not a triangle. And if it's not a triangle, you don't need to go through and figure out whether it's not an acute, obtuse, or right triangle. It's just not a triangle at all. Alright. Same sort of thing here. First thing I want to figure out is it a triangle? So we got 10 plus 15. That's 10, that's 16. And we want to know, is that bigger than 20? And sure enough, 25 is bigger than 20, so we're good on that count. So then we're going 10 squared plus 15 squared. And we want to know, is that less than, greater than, or equal to 20 squared? 10 squared is 100. 15 squared is 225. 20 squared is 400. 100 plus 225 is 325, which is less than 400. So if a squared plus b squared is less than c squared, that makes this obtuse. Okay, so it is a triangle, and it is obtuse. And as long as you've got like the obtuse or the acute part circled, I'll assume that you know it's a triangle. Okay, and one more of these. So we've got 15 plus 20, that gives you 30. Okay, 30 is bigger than 25, so yes, this is a triangle. So then we're going to 15 squared plus 20 squared. And we want to know, is that greater than, less than, or equal to 25 squared? 15 squared is 225. 20 squared is 400. 25 squared is 625. Yes, that is one I know off the top of my head. Some of these will just pop up enough that you eventually can rattle them off. If not, that's fine. Just go ahead and plug them into your calculator. Not a biggie. And 625 equals 675. So that one's a right triangle. Alright. And back. Okay, so the thing that you're going to want to jot down for the next couple is SOHCAHTOA. So take a second and jot that down if you haven't already. So sine is your opposite over hypotenuse, cosine is your adjacent over hypotenuse, tangent is your opposite over adjacent. That's something you're going to want to have jotted down because, again, the big thing is just not getting these mixed around and putting the wrong thing in the wrong spot. Alright, so if we've got this triangle, oops, a little right angle on there. We want to watch out for, do we want sine, do we want cosine, or do we want tangent? And if we've got this angle here, your longest side is always your hypotenuse. So that's your hypotenuse. The side that's not touching your angle is your opposite side. So the one across from that is your opposite side, which makes this your adjacent side. So we've got our opposite. We're looking for our adjacent, so that's OA. So we want our tangent. So we want to say the tangent of 42 is your opposite side, which is 10, over your adjacent side, which is x. And just a friendly reminder to take all of your calculators and stick them in degrees. So your tangent of 42 should give you 0.9004. So just go ahead and check for a moment, see if that does give you that. If it doesn't, you want to figure out how to change your calculator to degrees. And I went through that in the first video where we went through this, so hopefully you remember how to do that. If you don't, go ahead and email me. Alright, so once we've got this, we're going to take both sides and we're going to multiply it by x. So these are gone. We get x. And then we're going to take them both and we're going to divide by that 0.9004. 0.9004. those go. So 10 divided by 0.9004 is 11.1. Alright. And again, if we're looking back at our triangle, always a good idea to look back and make sure that that number at least makes sense. Okay, that's a bit more than 10, because this angle's going to be a little bit bigger than that angle, because that angle will be 48, that's 42. So this side's a little bit longer than that side. Okay, we're in the right ballpark. Which should be another giveaway if you happen to end up in radians instead of degrees. That should mess, like, everything up. Alright. Yeah, one more of those. And again, the big thing here is just figure out, do we want sine, do we want cosine, and do we want tangent. So if we got this angle, this one's our hypotenuse because it's your longest side. And again, your longest side is always the one that's across from your right angle. So if you're looking at it going, well, I don't know if that's longer or if that's longer. Miss P is always saying things aren't drawn to scale. You're right. It's the one that's across from your right angle. Because remember, your longest side has to be across from your biggest angle, and in a right triangle, that's going to be your right angle. So if we've got 70 degrees here, we've got our hypotenuse, we've got our adjacent side, because that's the one that's next to that. We've got our opposite side over here. So we've got adjacent, we've got hypotenuse, so that's the part of SOHCAHTOA. So you got the cosine of 70 is your adjacent side, which we're looking for, over your hypotenuse, which is 24. Cosine of 70 is just a number, which is about 0.342. And then we're getting rid of dividing by 24 by multiplying by 24. That does point a little bit bigger. So I'm going to take that 0.342 times 24, which gives you about 8.208. I'm fine if we call that 8.2. And again, okay, we're in the right ballpark. This is a bigger angle, which means that's going to be a longer side. That's a shorter side. 24 is going to be your longest one. So, okay, we're in the right ballpark. All right, one more of those. Whoops, I got smudged. Okay, this time we're looking for an angle, but same idea. We want to figure out, do we want sine, do we want cosine, do we want tangent? And if we've got our adjacent side, and we've got our hypotenuse, because this is across from your right angle that I didn't put the sign in there for. My bad. Okay, so we got our hypotenuse, we got our adjacent, that's AH, so that's the part again. So the cosine of the thing we're looking for, I called it theta here, you can call it x if that's a bit more comfortable. Adjacent is 6.7 over 8, but that's just a number. 6.7 divided by 8 is 0.8375. Okay, what do I want to do with this? So these ones you want to watch out for. We don't want to stop once we're there, because this isn't x, this is the cosine of x. So if we want to get rid of a cosine, we're going to inverse cosine. That's just going to cancel this out. So then x is going to be the inverse cosine of 0.8375. So make sure you hit shift and then cosine. At least that's what it is on my calculator. If you're not sure where that button is on yours, feel free to shoot me an email and I'll help you find it. Which gives you about 33 degrees. 0.1-ish. And when you're looking for that button, it might look like this, or it might look like this. Or it might say arc cosine. So it might look like that, or that. Hopefully you know where the button is from when we did this in the homework, but if you are either using a different calculator or you can't find it or you figure out where it was, just let me know. And I'll help you find that. And if your calculator doesn't have one, just type calculator into Google and it'll come up with one that does. Alright. Alright. These next couple, you're going to want to jot down the law of sines and the law of cosines. This one you probably remember off the top of your head. This one, maybe not so much. You might be able to get the a squared plus b squared part, because remember the Pythagorean theorem, but the rest of this, you want to make sure you jot these down somewhere. Just so you make sure you know what you're plugging in where. And I'm going to assume you've taken a moment to pause the video and jot those down if you didn't the first time we went through the law of cosines. So, law of sines, law of cosines. Right. And the first thing we're going to need to figure out is which one we're going to use. And you may notice on the directions these ones say solve the triangle, so that means we're looking for all of the stuff that we're missing. So this one we're actually looking for three things. We're looking for angle A. Marcus read it out. Okay, we're looking for angle A. We're looking for little a. And we're looking for little c. And remember, little a is across from big A, little b is across from big B, so we've already got that one. And then little c is across from big C. I don't know if you can hear my cat scratching on the door over there. Okay, so we're looking for those three things, and we just want to make sure that we get all of them. I'm actually going to jot these up here so that we have some more room down here. Okay, so this one we want the law of sines, and the reason we want the law of sines is because we have a pair where we've got an angle and the side across from it. So anytime you have one of those, you can use the law of sines. Or the other thing that is a clue that you can use that is we have two angles. Anytime we have two angles, we can use the law of sines, because as long as we have at least one of our other sides, we either have a side angle pair or we could find it because we can find the other angle right away. And actually the other angle is going to be the quickest thing to go ahead and find here, so we're just going to take 180 minus 45 minus 70, and that'll give you your third angle, which is 65. And there's my cat. Hi, Mirage. Are you here for Pet Day of Spirit Week? Okay, you gotta move now. That's like the third time she's shown up in this video. Okay, come on, scoot. Don't walk on that. Okay, if the next one's smudged, you know why. Okay, so that's one of our sides. And now we're going to use the law of sine, so we're going to say the sine of A, which we have now. We have A, so the sine is 65, over little a, which is the thing we're looking for, equals, and the pair that we have is B, so we're going to go with the sine of 70, over little b, which we're looking for. Nope, we're not looking for little b. We have little b. That's 15, Mirage. Okay, now, once we've got that, the sine of 65 and the sine of 70, those are just numbers. So we can plug in the sine of 65, which is about 0.906. And we can plug in the sine of 70, which is about 0.9397 over 15. And then we're just butterflying that. So yeah, 0.9397a equals whatever 15 times 0.906 is. 0.906 times 15 gives about 13.59. And then we're going to divide that by that 0.9397. 0.937. Which gives you about 14.5-ish. Alright, cool. Now we're going to do the same thing, but with the other angle and the other side. So instead of the sine of 65, we want the sine of 45. So I'm just going to erase this, save myself a little bit of room. Should have kept that number. That's okay. But now this is over C. Alright, and the sine of 45 is 0.707 over C equals whatever the sine of 70 was. That one was 0.9396 over 15. So now we got our 0.9396 again with C this time equals whatever 15 times 0.707 is, which is 10.605. And then we're dividing by that 0.9396. Which gives you about 11.3-ish. And just a heads up that if you rounded some of this a little bit differently up here, or you rounded something a little bit differently down here, you might get something slightly different around here. So if you got something like 11.2 or 11.4 instead, as long as they're in the right ballpark and you're showing your work, you're fine. So as long as it's a rounded thing, you're all good. We do want to make sure that we've got those three things. So just a heads up that those questions on the test will be worth 3 points. So you get a point for this, point for this, point for that. Okay, one more of these. And this time we're going to want... So this one, we want to use the law of cosines, and a good giveaway for that is we've got all three sides, we don't have any angles. So in order for the law of sines to work, we need at least one side angle pair, and we can't have that if we don't have any of the angles. So law of cosines here, and we're looking for A, B, and C, so it doesn't matter which version of our law of cosines we're starting off with, we just want to make sure we keep track of which thing we're looking for. So I'm going to start off with A. So we got A squared, which is 11.6. Plus b squared, which is equals b squared, which is 15.2 squared, plus c squared, which is 7.4 squared, minus 2 times b times c cosine of a. Hey, almost fit. Okay, there we go. Okay. And nicely, once we've got this plugged in, so it's a lot of stuff, but once we're here, we're really just solving for this. So, we got a lot of squares here, we're going to square them. So 11.6 squared is 134.56. 15.2 squared is 231.04. 7.4 squared is 54.76. And then we're going to take this times that times that. So 2 times 15.2 times 7.4. 224.96. Cosine of 8. And now we're going to combine some things. And watch out for when we're combining things, we're combining these two, not this one. So these two we can combine because they don't have variables. This one has a cosine of A attached to it, so we're not going to combine that. Okay, so we're going to add these two. So yeah, 134.56 equals these two added together, 231.04 plus 54.76. Gives you 285.8 minus 224.96 cosine of 8. So we're combining these two, but not combining it with that. So now we've got this, so we're going to subtract 285.8 minus 285.8. Those are gone. Watch out for it. Don't lose this negative, so that's going to give you a negative 151.24. So don't lose that negative, and don't lose this negative that's hanging out in front of your 224.96. Or if you're going to lose them, lose both of them, because they're about to cancel out when we do this. So we're dividing by that 224.96. This is negative, that's negative, so those are going to cancel each other out, which gives a 0.672. Okay, and again, watch out for that's not A, that's the cosine of A. So last thing we're going to do is inverse cosine that. So the inverse cosine of 0.672. Inverse cosine of 0.672 is about 47.8. Okay. All right. Now we're going to do the same thing with angle B. Okay, so same sort of thing though. So we're just going and starting with B instead. So we got 15.2 squared equals A squared plus C squared minus 2 times 11.6 times 7.4. And this time it's the cosine of B. Okay, so same idea as before. Our numbers are just going in a slightly different order this time. Alright, so we should have left up there what 15.2 squared was. 15.2 squared is... No, it's not. Oops, pressed the wrong number there. 15.2. 185.2. 231.04. 11.6 squared was 134.56. 7.4 squared is 54.76. And then we got 2 times 11.6 times 7.4 gives you 171.68 cosine of b. And again, we're combining these two, but not combining it with this one. So we're adding these two and not subtracting that one, because that one has a cosine of b attached to it. So we get 134.56 plus 54.76, which gives you 189.32. 189.32 cosine of b. 230.04. And they were subtracting 189.32. That's 189.32. Which gives you 41.72. And watch out for it, don't lose that negative there, because we're about to divide by that. So we're dividing by negative 171.68, and this time there's not one over here to cancel it out. So we're going to end up with a negative. And that negative is a 0.243 equals your cosine of b. And then the last thing we're doing is we're inverse cosining negative 0.243 negative 0.243 is 104. Okay, and then C, nice thing is you don't have to go through and do all of that again, because now we've got two of our angles, so we can just take 180 minus these two, so 180 minus 104 minus 47.8 gives you 28.2. And if we're taking a look at our triangle there, okay, those seem to be in the right ballpark. C is our shortest side. It's going to be across from our smallest angle. That's our smallest angle. That checks out. B is our biggest angle. That's across from our longest side. Okay, we're in the right ballpark. All right, so that is it for the review. On the shorter side as far as the number of questions, because the last three are really three different parts. So go ahead and email me now that you're done with the video. I'll give you a link to the test. Take your time, don't rush, because this is the only assignment this week, so don't freak out. Take your time, take some good notes. If you're not feeling comfortable, email me something before the test so that we can go through some more stuff. Want to try to make this as painless as possible. So go ahead and email me when you're done for a link to the test, and I will see you in the next video.